Hello everyone, this is the first lecture of railway system and this channel will help to understand the railway systems and operations. First of all, I would like to give you a brief about me. I am a railway graduate from University of Birmingham and experienced professional in planning department and an MBA from Manchester Business School. So, first of all, I would like to explain you why railways is a preferred mode of transportation. So, it's lower fuel cost, it's environmental friendly, large loads can be transported, and it is more reliable. Now, lower fuel cost in a sense that if it is electrified, then electricity produced from green source such as hydropower is much more cheaper than any other energy source. So that's why it's a lower fuel cost option. At the same time, it is environmental friendly since the carbon emissions are less per passenger per mile as compared to road transportation. Large loads can be transported efficiently because one freight train can carry a number of cars, which in case of road is only a few. And finally, it is a more reliable option since it doesn't face any congestion issue, which is in case of road is normal thing. So, railway system is composed of several systems, which are railway signaling and control, railway infrastructure, rolling stock, traction system, and operations. Operations are not part of railway system itself. However, I will explain this one in order to tell you how the railways are operated. So today I will just give you a brief about first railway system, which is railway signaling and control. Railway signaling and control system is perhaps the most complex and critical system because a small mistake can lead to a big disaster. Purpose of this system is to keep trains apart from each other while running on their specific routes and make journeys safe. In early days, drivers used to run trains on their side, which was not safe, especially in bad weather. Drivers' mistake in assessing trains ahead caused several accidents. So this side-based driving method was not safe. Later on, another method of control was introduced, which was time interval. In order to keep operations safe and trains well apart from each other, a time interval based method was adopted. Trains were allowed to run only after one another with a specific time interval such as 20, 30 and so on. However, any mechanical failure of trains on the roads caused back-end collisions, so it was not safe enough. At the same time, the line capacity was reduced because trains were not allowed with a fixed time interval. As soon as technology advanced and things get better towards mechanical infrastructure devices, another method, train stop-based method, was adopted. Various mechanical and electrical tools were deployed for the implementation of this system, which will be discussed in later videos one by one. Staff used to get a token from originating station and he would leave the token on the next station so that other driver on the next station would be able to drive his train. This system has some demerits, like trains would have to wait for a long time on stations and reduce line capacity. In some cases, wrong tokens were issued, which caused accident on branch lines. As you can see from this figure, the driver from the T1 train 1 will get a token from station 1. It will drive the train to the station 2 where it will drop the token, and the other driver for the other train T2 will get the token and then he will drive his train back to the station 1. So this was the simplest procedure of doing the train staff based signaling and control system. Later on, another method which is based on electrical systems and electronics is track circuit. Track circuits are used for keeping semaphore signals red until the specific section of track is occupied by a train. As soon as the track clears, the signal behind changes to red, which gives movement authority to the next train. However, without automatic train protection and train protection warning system, this becomes useless. It is because driver doesn't respect signal aspects when they are driving under tight schedule, which causes collisions with trains ahead. Because in these systems, the signal becomes red or green according to the occupancy of track, but it doesn't stop or prevents driver from entering that specific section of track. So it was not safe enough because driver was not obeying with the signal aspect. The most advanced and modern system which has been deployed in the signaling and control system is ETCS and CBTC. ETCS is a European train control system and communication-based train control system. This system doesn't only increases the line capacity, but it is more safe than other systems. There are usually 3 levels of ETCS. Level 3, which is the most advanced system, allows to run the trains very close. Train-based computer system interrupts the telegrams received from bellies about the location of train, speed of the train will be getting from the odometer, and braking performance data. All those things will be sent to RBC via GSMR in order to get the next movement of authority. Level 3 doesn't require any on-site signals. Now, in a separate lecture, I would like to explain this ETCS system in a detailed manner because it cannot be accommodated within this lecture. So that's it for today. I have given you a brief introduction of railway signaling and control system. Now my coming lectures will be providing you a detailed information about each of these systems, about their components, about their processes and everything. So stay tuned to my channel. Please like my channel and subscribe to my channel so that you can get the latest video. Thank you for today.